Alright, in this lesson we're going to talk about finding the inverse of a transformation matrix. We're going to look at just a general introduction of it first. So we're mainly going to discuss how to look at the individual matrices for transformations, such as scaling, rotating, and translating, and finding the inverse of each one of those individually. And when I say inverse, the best way to think of it is really just undoing a transformation that has been done. So when you invert a matrix that scales, you should get back to the original object that you had before the scaling happened. So you're undoing the scale, and so on. So let's go to the board and we'll look at really some examples. Okay, so let's start by looking at the scale matrix. So just the scale matrix on its own, not the inverse of it yet. Okay, so there's our scale matrix. And if we look at it from an algebraic standpoint, right, we're saying some x prime is the original point x times some scalar value. Our y prime, these are our translated points, is the original y multiplied by some y scalar value. Simply, that's exactly what this matrix does to the points that are passed in. Okay, so when we think about undoing it, right, we think about getting the original point back. So if we have a transformed point, right, what if I want to get x back? What would I have to do to the transformed point to get x back? Well, I mean, this is simple algebra. Let's just solve for the original point x instead of the transformed point, right? So the original point x is just, x prime over s of x. And our original y is just y prime over s of y. Right, so if we multiply by some number, right, if we multiply by 5, we get 5 times bigger, and if we divide by 5, we get 5 times smaller. So that would say that if we were to multiply by 5 and then divide by 5, it's like nothing ever happened. And that's exactly what we're doing. We're just undoing it by multiplying by 1 over that amount. So what would this look like in a matrix? Well, it would look like, go ahead and write it underneath. Okay, so our inverse then of a scale, sorry, here we go. So our scale inverse, right, is just 1 over s of x, 1 over s of y, 1, and that's it. It's that simple. These aren't really complicated at all. Now, if you did any linear algebra, then finding the inverse of a matrix can be sometimes complicated, not all the time, but still you run into that issue where what you have to do is put the identity matrix next to it, and then you use reduced row echelon form, and you just keep doing row reduction, just row ops on it until you end up getting the identity matrix on the other side, and whatever's left ends up being the inverse. And that you could do that, sure, but these are special matrices. These are transformation matrices. We know something about them, which helps us actually do these methods where it's actually simpler to find an inverse using just intuition and some algebra than doing that whole process where we actually do all that row reduction. So second, let's look at the rotation. So the rotation is cosine theta minus sine theta, sine theta, cosine theta, 0, 0, 1. Okay, that's our rotation. This again should be pretty simple if you think about it in this way. Well, let's say if I rotate, right? If I were to rotate by some amount, right, call it theta, like that, and I get this new point. I mean, it just stands to reason that if I want to undo that rotation, well, naturally I should be rotating by the exact same amount, theta, but in the other direction, so minus theta, right? If I rotate by minus theta, then I'm right back to where I started. And yeah, that's about it. So we're really, anytime we have cosine theta, would be, sorry, cosine of minus theta. Anytime we have sine of theta, we'll do sine of minus theta, right? But cosine of minus theta is actually the same as the cosine of theta. And sine of minus theta is the same as minus the sine of positive theta. So we're going to make that substitution immediately to write our inverse, okay? So our inverse rotation is cosine of minus theta, which is just here, cosine of theta. So that stays the same. This is our rotation inverse, okay? Minus the sine of minus theta. Well, that's like saying minus a minus, right? So this is just positive sine theta. And then we have minus sine theta. And we have cosine theta. Okay? So this is our inverse rotation. But you should notice something here. There's something special about the rotation inverse. And that is if you really look at it, look at the row of the original rotation matrix and compare it to the column of the inverse. They're the same, aren't they? Like cosine theta here, minus sine theta, 0, and 0. Well, we know that the transpose of a matrix is one where the rows and the columns have been switched, right? So this row becomes this column, and look, this row matches this column, and this row matches this column. So really, the rotation matrix, the rotation inverse is exactly the same as the transpose. So whenever we want to find the inverse of a rotation matrix, we just transpose it, and there you go. There's the inverse. That's simple. Okay, last one we want to look at is translation. And this looks like the following. We have some A value, some B value. And this translation is saying that we've moved over A units on the x-axis and B units on the y-axis. Part of me doesn't even want to bother drawing this because this idea is so simple, but why not? If I moved over 1, 2, 3 units to the right and 1 unit up, I'd be here. Let's say that's what this translation did. Well, how would I undo what I did? Well, I would move 1 down and I'd move 3 to the left and I'd get back. So really, this is the simplest one and most intuitive to understand, is that the inverse of the translation matrix is just minus the values of the original translation matrix. Right? If I go the other direction on the x and the other direction on the y, then I get back to where I started, because we're just traveling in a direction. So that's it. Our inverse scale is 1 over the scale. Our rotation is really just the transpose of the existing rotation. And our inverse translation is just going, the opposite, so negative of each one of the components of the translation. And this is how we would undo it. So what we're going to do in a little bit is, let's say I gave you a matrix like 4, minus 4, 0, 2, 2, 0, and let's do 7, 2, and 1. Alright, if I gave you this matrix, you should be able to find the inverse of it. Now you could do it the long way. You could put the identity next to it and you could do the row ops. But what I'm going to show you in the next video is how we can use what's called matrix decomposition, essentially to break this matrix into its corresponding scale rotation and translation matrix, right? Then we know how to find the inverse of each one of them very simply, and we'd be able to multiply them back together, and we'd end up with the overall inverse of the matrix, right? Because isn't this, if I told you this was the model to world matrix for something, right, we know that the model to world matrix is equal to some scale matrix multiplied by some rotation matrix multiplied by some translation matrix, right? I mean, we learned in this order. We learned this before, right? So it stands to reason that if I were to invert the translation, invert the rotation, and invert the scale, right, then I'd get the inverse that would bring me back, which would be world to model. However, intuitively you'd think you'd just find the inverse of all and then you would just multiply them together. There's something important to understand here that's not, this is not correct, what I just drew here. So, and here's why it's not correct. Because the point goes, on the right hand side all the time, right? So my point's going to get multiplied in this order. So first I'm scaling it, then I'm rotating it, then I'm translating it, and that gets me, over here, p prime, okay? But you always want to undo the last thing you did, right? So if I translated last, right, then I need to undo my translation first, right? I want to undo what I did. The last thing I did is what I want to undo first, which means I really want to undo the translation first. So I'm taking p prime and I'm multiplying it with this. Then I want to undo what I did second to last and then third to last. So really, first we're going to find the inverse of each one of these after we learn how to break up a matrix. Then we're going to invert the order and we're going to multiply them finally together in the opposite direction. And that should make some sense. And finally, that essentially will give us, instead of our model to world, it's our world to model, right? Which is really just our model to world inverse. Okay, so that's it, and I'll do an actual example. I'll probably do this example right here in the next video. All right, see you next time.